Hello everyone, I'm Garfield Guan. Here today, I want to deliver to you a presentation on an innovative rock fracturing technology using supercritical carbon dioxide to give us a safe, more efficient and sustainable rock fracturing process. Let's see what is supercritical carbon dioxide. Supercritical carbon dioxide is a state in parallel with the gas, liquid and solid state. With the temperature over 31.1 degrees Celsius and with the pressure over 7.38 megapascal, carbon dioxide will become supercritical. And in the supercritical state, the carbon dioxide will have zero viscosity. That's very important. With zero viscosity, these liquid-like materials can seep through the original cleavage tips of the rocks very easily. When at the very small tip of the rock cleavage, very small forces can generate a very large pressure. If that pressure is over the tensile strength of the rock will be fractured. And that is the philosophy we use to develop this rock fracturing technology based on supercritical carbon dioxide. Now let's look at the fracturing process. The basic physics of the fracturing process is the impulse theory. When we want to fracture something, we need to exert an impulse onto that thing. And when we use SiCO2, you can see that the density is higher than the gas form of blasting air. So we can use a smaller change of velocity to give the same impulse. And on the other side, when we use SiCO2 fracturing, we need to only conquer the tensile strength of the rock that is much smaller than the compressive strength. And then we have a lower F, and then we can exert impulse into a longer time. So that we would have a fracturing process happening in a longer time and with smaller change of velocity, and that actually is a more gentle process of fracturing than conventional blasting. And even more, when the SiCO2 have done this work to fracture the rock, it will lose some of its inertial energy, and then it will become the gas form. When it becomes gas form, it has a volume much higher, about hundreds of times than the original SiCO2. And this volume of gas will squeeze the SiCO2 to progress even further. So this fracturing is a progressive fracturing process. And in this fracturing process, you can see the result of using SiCO2 is quite different from hydraulic fracturing and from the conventional blasting fracturing. And you can read the three photos on the bottom of the slide. On the third photos is by the blasting fracturing. Blasting fracturing need to conquer the compressive strength, which is over 10 or 20 times of the tensile strength. So the whole process is quite strong. And actually, it generates very small cracks in the surrounding. But when you look at the third photo, when we use SiCO2, it only cracks the rocks into smaller pieces by conquering its tensile strength. So you can see that we have scattering separated cracks, a series of them, then the rock is fractured. The whole process is more gentle, and it's quite good to be used in, say, Hong Kong urbanization and density location. And based on all this theory, we develop these things and assemble them into a product. And the key of the product is we call it CO2 tube. And with that CO2 tube, we can carry out this fracturing process of SiCO2, quite similar analogy to the process of blasting, which is quite familiar by the civil engineering industry. And here is the project we have done using this SiCO2 fracturing technology for civil engineering works, rock works and earthworks, and commonly it would be used for excavation and perhaps for tunneling excavation. And on the figures on the top left, we can see the scenario of the SiCO2 releasing from our CO2 tube. And on the right top, you can see the projects we have accomplished in mainland China mostly, and any more is coming on. And on the bottom slide, we can see we have some vibration monitor of this technology just right next to the vicinity of the SiCO2 fracturing. And the result is much smaller compared with conventional blasting. This technology has been used in more than 20 projects in mainland China. And it has been recognized by the academia. We have more than 20 patents, and also have been awarded the highest award in this industry in mainland China. And if you are interested, please go to the website and refer to my full paper. And this concludes my GED talk. Thank you very much.